Let g be a differentiable function of two real variables, and let f be the function of a complex variable z defined by f of z is equal to e to the x sine y plus I g of x and y, where x and y are the real and imaginary parts of z, respectively. If f is an analytic function on the complex plane, then g of 3 minus 2 minus g of 1 2 is equal to which of these options? Okay, so my first instinct here is to write down the, I don't remember what they're called, is it the Cauchy-Lagrange equations? The PDEs that, you know, the real and imaginary parts of an analytic function have to satisfy, or a holomorphic function, whatever. And we should be able to back out what this function g is, and then solve for g, and then just plug things in. Maybe there's a quicker way of doing this, but I think that's probably what I'm going to do. So let's start with what we're given here. We have f of z is equal to e to the x sine y plus I g of xy. So in general, if I have f, let's just say f of xy is equal to u of xy plus I v of xy. I believe, if memory serves me correctly, the conditions for the function to be holomorphic are the following. I think, if my memory serves me correct, I think that's what it is. I know how to derive them, but for the moment I'm going to go with this. And if I come to an answer which is not one of the options, then I'll derive. I don't even remember it's Cauchy something, right? But gosh, it's been so long since I've done this. Okay, so in this case, of course, u of xy is equal to e to the x sine y. So then, and v is g. V of xy is equal to g of xy. So I have e to the x sine y is equal to di g di y. And if I take a partial with respect to y, I have e to the x cos y is equal to di g di x negative. Okay, so from the first equation, we have g of xy is equal to e to the x cos y with a negative sign plus an arbitrary function of x. Okay, and now let's move that negative sign over there. Now if I differentiate g, I have di g by di x is equal to negative e to the x cos y plus h prime of x, and that has to equal negative e to the x cosine of y. Okay, and this tells us that h of x is a constant c. Okay, so at the end of the day, we have f of xy is equal to e to the x sine y plus, or minus, e to the x cos y I plus some constant c times I. Oh, we don't actually need the whole function f. We just need g. So g of xy, like I said earlier, is negative e vx cos y plus a constant. And we need to compute g of 3, 2 minus g of 1, 2. So this is negative e to the 3 cos 2 plus c minus negative e cos 2 plus c. So that should give us negative e cubed cosine 2 plus e cosine 2. Is this one of the options? We can factor out e. Well, no, the way they've written it, they factor out cosine 2. So yeah, they write this as e minus e cubed cosine of 2, which is answer E. Yeah. So, I mean, all of this, I end up with one of the options that they've given. This all depends, of course, on whether I remembered this series of PDEs or system of PDEs correctly. God, what is it called? Cauchy-Laplace? Cauchy-Lagrange? Ah, man. Complex analysis used to be one of my favorite areas. It's still really cool, but I just haven't studied it in such a long time. I've studied enough to remember this, I guess. Yeah, so assuming that's right and assuming I didn't make any silly mistakes with derivatives or integrals, I'm pretty confident that this is the correct answer. But if I find a mistake, I'll be sure to highlight it in the video. Thanks for watching.